In the last video, we discussed about how to organize categorical data, or if the data are not numbers, then how do we put them, how do we write them in a frequency distribution table? That's what we did, right? So to organize the categorical data, if the data is given like a raw form like this, and to write in the frequency distribution table, what we do is we need 4 columns, right? The first column we write the class, we call class, where we list all the different categories in the data. For example, here A, B, and O are the different categories. And in the B, we count how many are A, how many times A is repeated, and you write down like that. You write down tally, right? And there are 5, meaning you write like this, and then so on. And in the third column, you write the number for those tallies. And on the fourth, we write the percentage, that is the frequency divided by the total frequency times the 100%. So that's how we put, or we organize the data, categorical data, in frequency distribution table. So the next thing we want to do is, if the data is given in numbers or numerical data or quantitative data, how do we organize this data in a frequency distribution table? Okay, how do we make a frequency distribution table? So for this type of table, we call the grouped frequency distribution table, meaning we make groups of the data. Okay, for example, suppose that you are trying to study what is the average age of the people that died from COVID-19 in a certain county, okay, or in a certain state. And then what you do is you pick the sample of the data, okay, so you go to certain county and then pick this sample of, let's say, 20 deaths, and then record the age. Let's say, suppose you got the age of the people that died from the COVID-19 in a certain county, let's say 87 years, and then let's say 82 years, 75 years, let's say another person maybe 19 years, right? 42 years, another person maybe, let's say 91 years, let's say 64 years, and so on. Okay, suppose that the biggest data, okay, suppose the biggest data is this one, and the smallest data is that one, meaning the oldest people that died of the COVID-19 was 91 years old, and the youngest person that died of the COVID-19, suppose in that counting, is 19 years old, and there are so many other samples that you collected. Okay, suppose that is the case. So after you collect the data, the next thing you do is organize the data or make the frequency distribution table from this data. Okay, I will present a couple more examples later, but this is just for example that how we organize the data. But later I will give a complete example. Okay, so let us read what are the rules for to make a grouped frequency distribution. Meaning, if the data are numerical, if the data are number, then how do we write these raw data? Okay, this is the raw data, right? Raw data. So how do we write this data in a nice tabular form? Okay, when the range of data is large, we need to group the data into classes. This type of table is called grouped frequency distribution table. Following are the points to consider when we make grouped frequency distribution table. So the number of classes classes must be between 5 and 20. Okay, so for the grouped frequency distribution table, there are at least 3 or 4, you can say 3 or 4 columns that you will need. Okay, so first of all, before make a table, we will need some of the discussion, and then we will start to make the table. Okay, so the number of classes must be between 5 and 20. So how many classes should you make? In the previous example, we had how the classes were basically the different categories were the classes. Okay, but here, since all the data are numbers, so how many classes should we make? Okay, so that depends on you. So don't choose just one or two classes like that, or don't choose many classes. So usually if you choose number of classes between 5 and 20, that looks good. Okay, that should be okay. Now what should be the class width? The class width is calculated by this formula: largest data minus smallest data over number of classes. Okay, let us see on this example. Suppose I want to make 5 classes. Okay, so I will have a column for class. The first column will be class. Okay, so the second column will be class limits, and then class boundary, and then frequency. Okay, so there will be at least 4 columns that you will need. But first of all, suppose I want to make, let's say, 5 classes. Okay, now if I want to make the 5 classes, there will be first class, there will be second class, third class, fourth class, fifth class, like that, right? Now the question here is, what should be the class width? What should be the first number and then the second number on the first class, and what will be the first number and second number on the second class? That is the very important thing. Okay, so if you want to make 5 classes, to make the class width of, let's say, this data, okay, so what is the formula? The largest data minus smallest data divided by number of classes. Okay, so what is the largest data here? Largest data is 91. Okay, so the class width for the above example will be 91 minus 19 divided by 5, because you want to make number of 5 classes, right? Number of classes is 5. What is 91 minus 19? Is that 72? So 72 divided by 5. How much is that? So that will be 14.1. Okay, you see that? So 72 divided by 5 will be 72 divided by 5 is 14.4 actually. So 14.4. Okay. If the quotient is a decimal number, always round it up to the integer value. So you always round up. It does not matter whether this decimal value is less than 5 or greater than 5. Always round up for the class width. That will be 15. Okay. Now, so how do I make the classes then? So we let's make the class. This is class limit. First of all, we make the class limit, and then we will make the class boundary after that. Okay. Let's make the class limit. Okay. So we choose 5 classes, and we know what should be the class width. The class width is 15. Always round it up. It does not matter what decimal you get, round it up to a nearest integer. Okay. Now, after you determine the number of classes and the class width, construct a table with 4 columns. This is the first column, second column, third column, and the fourth column. Okay. The first column is class limit. The second column is class boundary. Let me write class and then boundary, BDRY in short. So class boundary. The third column is tally, and fourth column is the frequency. Let's just write down F. Okay, so this is how we construct a group frequency distribution table. First column is the class limit, second column is the class boundary, third column is the tally, and the fourth column is the frequency. So the tally and frequency is similar to the previous one. So let us focus on how do we write class limit and class boundaries. Okay, let us look at the class limit here. Okay, the lower limit of the class first class in the class limit is the smallest data point. So what is the smallest data point in our example here? Smallest, we assume 19, right? So there are so many other data. I did not write that data here. Okay, but there may be so many other data too. So I just write the dots. Okay, now but what I noted here is 19 is the smallest, and then 91 is the biggest, and we also say that the class width is 15. Okay, now so the first number on the class limit is the smallest data point. What was the smallest data point? That was 19, right? Let me erase this dash and then write down 19 there. So the first limit or the lower limit of the first class is smallest data point. Now, how do I find the upper limit or another number on the first class? So the classes in the group frequency distribution will be one number to another number, and the next number to another number, and next number to another number. It will look like that. Okay, so to find out the upper limit of the classes, we will use some formula there. But by the way, let me tell you how to find out the lower limit of each class. The first class is 19, right? The lower limit, the first number of the first class, or the lower limit we call. Lower limit of the first class is 19. Now to find out the lower limit of the second class, third class, fourth class, and fifth class, what we do is you add the class width to that number. Okay, so what is 19 plus 15 is 34, right? So let me write down that. Let me erase this dash first, and then write down 19 plus 15 is 34. 34, right? Now 34 plus 15 is 49. That is the lower limit of the second class. That is the lower limit of the third class. Now 49 plus 15 is 64. And 64 plus 15 is, what is that? 79. That's what you get. These are the lower limits. Okay, this is the lower limit of the first class, lower limit of the second class, lower limit of the third class, lower limit of the fourth class, lower limit of the fifth class, and so on. Now we need to write the upper limits. Okay, so how do I find the upper limits? Look at the formula here. If the data have no decimal numbers, then upper limits equals to lower limit plus class width minus 1. Okay, if the so if the data have no decimal numbers, then the upper limit is equals to lower limit plus class width minus 1. So what is the lower limit plus class width? So 19 plus 15 is 34, minus 1 will be 33. Look at this. Again, if the data have no decimal numbers. If the data have decimal numbers, okay, if the data have decimal numbers, then in that case, you will have to do minus. If there is one decimal, then do minus 0.1. If there is two decimal, then do minus 0.01, and so on. Okay, so here what we do is, as it is stated here, we add so the lower limit of the first class is the smallest data point. We add the class width to find the lower limit of the next class. Okay, in this way we fill all the lower limits. The upper limits of the classes are determined by the class width and the number of digits after the decimal in the data. So here on our data, what I did here is I added the class width here, and then class width on this number, and got the another lower limit, the next lower limit. To find out the upper limit of this class, first class, what I did is I did 19 plus the class width 15 minus 1, because there is no data points. There is no decimal in the data. If the data has one decimal, then that will be a little bit changed. We will see in an example. Okay, these lower limits will be a little bit changed. The first lower limit will be the same, but the second, third, fourth lower limit will be a little bit changed. We will see that. Okay, all right. So now, how do I find out the upper limit of the second class and third class, fourth class, fifth class? Is exactly the same way. You add the class width to the upper limit to get the upper limit of the second class. So what is 33 plus 15 is 48, right? 48. And 48 plus 15 will be, how much would that be? 63, right? And what is 63 plus 15 will be 78. And 78 plus 15 will be, how much would that be? 93. These are the class limits. See? So the main thing here is finding the first class. The lower limit of the first class is the lowest data. The upper limit of the first class, it depends on the data. If the data have no decimals, then you add the class width through the lower limit. 19 plus 15 will be 34, and then to subtract 1. Minus 1 is 33. Okay, so 1 less than that, 1 less than that, 1 less than that, and so on. Okay, now if the data have decimal, we will do one example later. Okay, you will have, if the data have one decimal, you will have to do the lower limit plus the class width minus 0.1. If there are two decimals in the data, then we do minus 0.01, and so on. Okay, now look at that. That's what this says. So if the data have one digits after decimal, then the upper limit will be lower limit plus class width minus 0.1. Similarly, upper limit equals to If there are two decimals, then upper limit equals to class width, lower limit plus class width minus 0.01 and so on. After you find out the upper limit of the first class, you can add the class width to find out the upper limit of the next class and the so on. Okay. Next thing is classes must be mutually exclusive. In case of the class limit, classes must be mutually exclusive, meaning all the numbers including 19 between 19 and 33, including 19 and 33, meaning all the numbers between these two including the boundary are on the first class. We will count in the data how many data are between 19 and 33 including 19 and 33, and you count on the first. So you will write down how many here. Okay. Similarly, between 34 and 48, you count on the second class, and similarly third class, fourth class, like that. But what it says is, if you are writing a table using the class limit, the classes must be disjoint or mutually exclusive, meaning if a number falls here, the number should not fall here. Okay, because anything between 19 and 33 including 19 and 33 are in the first class, but starting from 34 through 48 including these boundaries are on the second class. So no number falls in the two classes here. That's what the mutually exclusive means. Okay, the upper limit of the last class may or may not be the largest data point. What it says is, so here the largest data we said 91, but the upper limit of the last class goes through 93. Okay, so sometimes you will get exactly the same value there, sometimes you get different value, but no worries. This the upper limit of the last class may be any number there, but you should follow that 79 plus 15 minus 1 is 93. It may be the biggest number or not. No worries about that. Next is we find out the class boundaries. Okay, so how do we find the class boundaries? Is the class boundaries are calculated to avoid the gaps between the classes. Look at this. The data on the first class, anything between 19 and 33, including 19 and 33, 19 through 33 falls on the first class. 34 through 48 falls on the second class. But how about 33.5 or 33.6? So those type of data, they do not fall in the first and second class. So there is a gap between the classes. Okay, so the class limit has a gap between the class. So to fulfill that gap, we write class boundary, CL boundary. That's what I wrote here. So the class boundary is very easy to find out. Okay, let us look at the rule here. To find out the class boundaries, we use following. Okay, how do I do that? So if the class limit have no decimals, we add 0.5 to the upper limit and subtract 0.5 from the lower limit. What does it say? If the class limit have no decimals, there is no decimals here, right, in the class limit. So what do we do there then? So what we do is, to find out the class boundary, we add 0.5. If the class limits are all whole numbers, then we add 0.5 here and subtract 0.5 from here. So how does the class boundary look like? So that will be 18.5 through 33.5. Look at that. So we add 0.5 on the all upper limits and subtract 0.5 from the lower limit. So what do you get? If you subtract 0.5 from here, you will get 33.5 through 48.5. Okay. Similarly, subtract 0.5 from here. So you will get 48.5 through 63.5. Another is 63.5 through 78.5. Okay, and then 78.5 through 93.5. So again, if the class limit do not have decimals, to find out the class boundary, always subtract 0.5 from the lower limits and always add 0.5 from the upper limit. So what decided 0.5? The thing is, this is the gap. The gap between this number and that number is 1. So half of the 1 is 0.5. That's what we did here. Okay. All right. That's how we find out the class boundary. Now to find out the tally, it is easy, right? How do I do that? Is exactly the same way that we did. How many data falls between 18.5 and 33.5, or how many data falls between 19 and 33 including that? You write down, you count data 1, just 1, right? 1. There may be other, this is just an example. And how many data are between 34 and 48? including or 33.5 and 48.5. So you count there, okay? 1. So there is 1, 1 like that. And then you count the other values too. And you write down there. Okay. So one of the difference between the class limit and the class boundary is the class limit are disjoint and class limit are not overlapping. Okay, there is a gap between the numbers in the class limit because the numbers through 19 and 33 falls in the first class and 34 to 48 falls in the second class. But here it says 18.5 through 33.5 and it starts with 33.5. There is no gap. See, the number you get here, you start with the same number. You get here, you start with the same number, and so on. Now, your question may be, if there is a data point that has, let's say, 33.5, then do we count that in the first class or the second class? That is the very good question, right? But always keep this in mind that the upper limit of each class in the class boundary or the upper boundary of each class in the class boundary falls in the second class or the next class, okay? So 33.5 will be counted here. 48.5 will be counted in this class, okay? So if there is a data that is 33.5, that will be counted like 1, 1. So it will be 2 here because we have 42 and 33.5, right? So that will be counted on the second class, all right? So the upper limit of the class, upper boundary of the classes will be counted in the next class. So this is basic idea on how to find out the class limit or class boundary. For the class boundary, if the class limit have 1 digit after decimal, we add 0.05 on the upper limit. So if there is no decimal, then we add and subtract 0.5 from the class limits. And if there is a decimal in the class limit, then we subtract 0.05 from the lower limits and add 0.05 from to the upper limits, and so on. If there are 2 decimals, then 0.005 and so on. Let us see an example for this, okay? Find the class boundaries for the following classes. Look at this, 10 through 14. This is the class limit. This is the class limit, okay? We need to find out the class boundary. So there is no decimal here, right? So since the limits have no decimals, we subtract 0.5 from the left or the first number and then add 0.5 to the second number. So what is the class boundary? The class boundary will be 10 minus 0.5 will be 9.5 and 14 plus 0.5 will be 14.5. How about this? There is 1 decimal place. There is 1 digit after the decimal, right? So what we do is, this is the class limit. So to find out the class boundary, we do 0.05 as we mentioned here. Okay? So for 1 decimal, 0.05. For 2 decimal, 0.005. You subtract from the left and add to the right. That's what you will get 1.45 because 1.5 minus 0.05 will be 1.45 minus, through 6.95 because 6.9 plus 0.05 will be 6.95. Here there are 2 digits after decimal, so we subtract and add 0.005. That's what you get. Okay. Now, a data equal to lower boundary of a class belong to that class, but a data that is equal to the upper boundary of a class belong to the next class. That's what I just mentioned. But in the class limit, both upper and lower limit belong to that class. After you write the class boundaries, count the data that are in the respective classes and write their tally and numerical values. That's what we did, right? So after you write the classes limit or class boundary, you count how many data fall in that class limit or class boundary and then write down the tally, write down the corresponding number in the frequency. That is how you make the frequency distribution table for the quantitative data, for the numerical data. Okay. Let us talk one more thing here, the cumulative frequencies. Sometimes we evaluate cumulative frequency distribution. For this, we create a table of 2 columns for the cumulative frequency table. The first column contains less than or lower bound. We need to find out the class boundaries first. Class boundaries, okay, of all class boundaries and upper bound of the last class. And the second column contains number of data points that are less than the boundaries of the class, called cumulative frequency. For example, in this example, if you want to find out the cumulative frequency distribution table, you will need 2 columns. One is less than and the other is the cumulative frequency. We denote by CF. And what is the lower limit of the first class in our in our table here, the lower limit of the first class was first class lower boundary, I'm sorry, not lower limit, lower boundary of the first class is 18.5. So what we do is we write less than 18.5. So how many data are less than 18.5? Because the smallest data was 19, there are no data less than 18.5. So we write 0 here. Less than 33.5. So how many data were less than 33.5? There was 2 data, right? Or 1 data. So 33.5 were 2 data or 1. You count, okay? So how many data were less than 33.5? Not 33.5. I said less than. Oh, there was 1. Because less than 33.5 were only 1. Because 33.5 is counted on the second class, okay? So there were only 1 in the less than 33.5. The number of data that are less than 33.5 was only 1. And another was 48.5. So there were, how many data were there? So there was 1 data less than 33.5, and between 33.5 and 48.5 there were 2 data. So the total is 3. Basically, how do we find out the cumulative frequency is? You start to add the frequencies, okay? So for the first one it is, very first one it is 0, and less than 33.5 is 1, and less than 48.5 will be 1 plus 2 will be 3, and then so on, because the first one is 0, less than 18.5 is 0, less than 33.5 is 1, less than 48.5 is 1 plus 2, and another is that 3 plus something, and you keep adding the frequencies, okay? We'll see in an example, no worries about. And sometimes we find class midpoints. So you need to find out the class midpoint sometimes. We will see that later. But how do I find out the class midpoint? Is we add the lower limit or lower boundary and then upper limit or upper boundary and divide by 2. Okay. So just the average of the limits, upper and lower limits, or upper and lower boundary, and divide by 2 for each class. Okay. So let me stop this video here, and in the next video I'll show you an example on how do I make a frequency distribution table for numerical data. Okay guys, thank you.